Here we'll be talking about the normal distribution for determining sufficient statistics. So what do? We are still talking about factorization theorem. Here we have the normal distribution, and the parameter is mu. The parameter for this distribution is mu. So if we take the product of this function, that means we take the product of this ranging from 1 to n. What it will give us at the end of the day is this 1 over square root of 2 pi sigma squared n exponential negative 1 over 2 sigma squared summation of I ranging from 1 to n x t minus mu whole squared. So if we take the product, this is what we get as the end product. But recall, before we proceed, recall from quadratic we have that a minus b all squared is equal to a squared minus 2ab plus b squared. On the same vein, if we have xt minus mu all squared, we'll have this same thing here. That means xt squared minus 2 mu xt plus mu squared. And if we take the sum, that means the sum of this, we have summation of xt all squared minus 2 mu summation xt plus, if you sum this is a constant. If you sum this, you have n mu squared. So what it means is that the whole of this is equal to this. So we proceed further to this point. That means our function, which is f, we reduce it this time because of space. We are talking about mu here. Will be equal to, we take this 1 over square root of 2 pi sigma squared all over n exponential 1 all over 2 sigma squared. We now bring the whole of this and put it here to give us summation xt squared minus 2 mu summation xt plus n mu squared. So this is what we get. This is what we get. Now, how do we factor out these things? Now we're talking about mu. So we'll bring out all the mu one side. All the functions that are attached to the mu, we'll bring them one side. And all the functions that are not attached to mu, we'll bring them one side. For this, we also note that this can multiply the whole of this. We open that bracket. So we have 1 over square root of 2 exponential. We are now multiplying the whole of this with this. You have this multiplied by this. We have minus summation of x t squared all over 2 pi 2 sigma squared. This multiplied by this will get plus 2 mu sigma st all over 2 sigma. This multiplied by this, you have minus n mu squared all over 2 sigma squared. So this is what we have. And we know that this is still our function. So what do we do? How do we factor all of these things out? For we to factor this out, we'll now separate the ones with mu to one side and the ones with only sigma to the other side. But we have to remember that exponential a plus b plus c is the same thing as exponential a multiplied by b multiplied by c. So if you watch it, we can open this. This is without mu. This is with mu, and this is with mu. So we can do that. But before we do that, we'll see that these two can cancel these two. So we'll be left with 1 all over, let's write out the function xt, our parameter is just mu. So we'll be left with 1 all over square root of 2 pi sigma n exponential summation of xt squared all over 2 sigma squared. From this, we can also have another exponential, the whole of this mu summation of xt all over sigma squared minus n mu raised to the power of 2 sigma squared. So this is what we have. How do we now factor it out? We just bring this one side and put these other ones to the other side. How do we go about it? It will be f xt mu is equal to exponential. For the first complement, we have this xt over sigma squared minus n mu squared over 2 sigma squared. We also bring this here 1 all over square root of 2 pi sigma squared exponential this summation of xt plus squared all over 2 sigma squared. As simple as ABCD. This is now our first component, while this is the second component. It means the whole of this is our mu, our 5 mu summation of xi and the component mu. While the whole of this is our h, x1, x2 to xn. So we can say for sure that the summation of xt is a sufficient statistics for mu, because we have been able to separate them into two components. That is to say, our final answer is already there. We can conclude by saying, let's write it, f of xt mu is equal to exponential mu summation of xt all over sigma squared minus n mu squared all over 2 sigma squared multiplied by 1 all over square root of 2 pi sigma squared n exponential summation of xt all squared all over 2 sigma squared. So the whole of this becomes our phi mu summation of xt mu, and the whole of this gives us h x1 x2 to xn. Hence summation of xt is sufficient statistics for mu. So this is how to obtain the sufficient statistics for the normal distribution.